Boys and girls, ladies and gentlemen, Jesse Warden here. Today we're going to do a effect crash course.
Jesse Warden.
Why are we doing an effect crash course? Well, the famous Matt Pocock has been talking about the effect library and how weird it is, but yet how amazing it is once you go in. You'll never want to go out. And I totally forgot. I gave this presentation to the Richmond JavaScript user group back in January, and now it's July. So I figured, hey, I'll catch you all up. So I just wanted to give a crash course, but it gives you kind of an idea of what Effect can offer, but also it's a ramp up. You don't have to use everything, which I think a lot of people kind of get overwhelmed by Effect, and it's grown a lot in the past 6 months. It's grown a lot in the past year, but it's okay. You can still use pieces. Talk about it. Let's talk about what it is, why you'd use it, notable features that I like, other features to learn more about, and it keeps getting compared to RxJS a little bit, which I think is not accurate. So anyway, what is it? Well, it's a library to write composable programs in production grade TypeScript. When they say production grade, they mean everything is typed well, including errors. So when you ship to production, if the types compile, you feel really confident it goes there. Just because Angular compiles, for example, doesn't mean that every possible scenario is covered. Angular is great from a component, runtime, and observable perspective, including signals, but they just don't have the type safety that like some types and some of the error types and observable just aren't there, and they are in effect. So that's an example of when they say production grade, what do they mean? It means that the types are really, really a big part of it. It also has concurrency, so it's easier to do retry things. It's easier to pause and do network effects and organize concurrent operations beyond just do them all at once or do one at a time, like, promise.all or array.from. It has all kinds of controls around that, and it's kind of just expected. It's composable, so you can pipe with type-safe effects together, but you can also rerun them. You can do imperative async operations. So you'll see a lot of this generator function and yield syntax, but they both kind of do the same thing. You compose these things together into pipelines or compose functions together. It's always been a big missing point of JavaScript. When functional programmers come over, they're like, where is this stuff? Effect has it built in. It's also got resource safety. If you've ever used Folktail Task, it kind of allows promises to be aborted with the opportunity to clean up. So promises, once they're started, you can't stop them. You can stop the network effect, but the promise keeps going, right? So if the promise is doing all kinds of stuff, like maybe a long function with async await, there's no way to like stop it per se or cancel it. And when I talk about type safety a lot, that's because it's not just for functions and pipes, but also errors. So errors is not something you hear a lot about in TypeScript or programming in general, unless you come from a functional background. That's not because it has anything to do with functional programming. It's just that functional programming tends to have the better type systems. I think Rust was kind of one of the first to really popularize, hey, you can write imperative code or even OOP-ish or, non-functional code, but the type system is really good, right? And so type safety was a big thing. So functions and pipes, when you compose these things together, it helps to know if you put a function together and what comes out and goes into this function, hopefully the types match up. So compilers can help there. But errors are a big part of that. If these functions can fail, and how do you handle those errors? Dependencies is also huge because most people, when they think about dependency injection, they think, if they're from C# and Java, like dependency injection frameworks, but they never really talk about how do I type that, right? It's just the class should fit the interface contract, right? Well, what if you could do layers of that, and so you didn't have to have a hierarchy, but it was still typed? Like crazy cool things like that. Error handling, a lot of expected ways to handle errors in a type-safe way. So you don't have to go, oh no, this could throw at runtime. There's no way to type that in TypeScript. We don't have checked exceptions. Well, Effect has a variety of ways to guarantee that you know every single possible error that could ever come out of your function or compose functions or program. Pretty rad. Async. The sync and async kind of feel the same, which I think is very similar to one of the draws from RxJS. If you understand anything about RxJS, understand that when it came out, promise wasn't native in the browser or Node. Callbacks were still kind of a thing. And there was no real way to unify all of this stuff that was happening around synchronous, asynchronous, promises, callbacks. None of that was really there. And Lodash was popularizing kind of composing things together, right? That's kind of what RxJS got popular because it came out at that time frame to make kind of everything feel the same from an API. You get that same feel in Effect. Observability. So one of the nice things about having a effect composable is that if you ever mess with like maybes or results or eithers or option types in other languages, there are ways to like map a series of things together, like optional. It's undefined or not. It has a value. It's a success or failure. Very similar to promise. You have ... then, but only catch in one place. Wouldn't it be cool to have every single one of those have a before and after? If you're ever familiar with, I think Java calls it aspect-oriented programming. That observability is kind of built into Effect. So you don't have to tack it on yourself. It's just built in. For node developers and server side, this is pretty important. Front end developers, you really don't care that much. But in the back end, it's nice to have built in Trace ID so you don't have to set up OTel after the fact or New Relic or AWS X-Ray, things like that. So going back to concurrency, if you remember Bluebird Map, it was one of the ways where you could do a limited amount of concurrency. That was one of the nice things that was, I think, ahead of its time. Effect kind of just build that stuff in. So if you have 100 promises that all have to go at once, but you only want 3 at a time, you can do that kind of stuff. Folktale, Sanctuary, True Myth. If you know those kind of libraries, you'll know the basics of Effect, which is like massive, massive head start. You'll be fine. So functional programming philosophy is kind of what Effect comes on. The types describe effects, I think, was kind of borrowed from like Scala and Zio, but a lot of it from the non-Scala crowd is really errors as values, right? That's kind of the main point of it. And it discredits Effect to say it's just for errors, but I think a lot of people who've never coded with errors as types before get kind of confused. Like, wait a minute, like there's a lot of things that can go wrong with my function. There's 5 of them. Do I really care about it? If you've ever done like Python or Java, like reading a file, for example, you might have seen an exception switch where they're like checking exceptions at runtime or class of errors at runtime, like what type of error it was. Sometimes they handle all, sometimes they kind of group them into a singular exception. But the idea that you can, from a compiler perspective, know what can go wrong is kind of new. You don't have to run the code to see it explode and know what went wrong. You have the type system tell you, which is kind of amazing. So that way, when you compile, it works. You get closer to that ideal. So that's kind of the two philosophies we're really talking about when we talk about effect. So the philosophy why errors is values instead of exceptions. Let's take a look at this load people function. I'm just doing JavaScript just to start. Ignore the types for a minute. And let's talk about all the things that can go wrong with this function. First, no catch, right? If somebody uses this function, they could add a catch because promises are kind of composable monads like that. But the idea is like there's no error handling at all. The second problem is that no one checks the response is okay. So if you get a 400 or 500 HTTP response from fetch, no one handles that. The RxJSON can fail. So you could try to parse JSON, but you've got some kind of HTML from Nginx or XML from a SOAP service, something weird. And the JSON just fails, or maybe the schema is gone. Even if that succeeds, it might not be the shape, or in this case, the ZOD, type system you want. It might not match your type. And so that's another thing you have to check. So if you were to like expound upon that and say, all right, let's do all that error handling, you're still going to miss things. So even if you have like, okay, if it's okay, the response comes back and we parse the JSON and we make sure ZOD is done in an unsafe parse way because inside a promise, it'll catch, you still have to check things at runtime. And that's one of the uncool things is that error instance of is not only just a type, but it's also a superclass. So it could be any of subtype of error. So you don't even get that like strict identification of those types. If you ever used variants or some types, or in TypeScript's case, discriminated unions, that would let you know what type of error it is, but this kind of code shows it's not there. And then notice how it's usually an error of a type unknown. So you have to check if it is before you can confidently get a dot message property. Otherwise you like stringify it maybe, right? Or just log out the error. So little things like this just make errors kind of unintuitive, which is why most people don't do it, even in TypeScript, right? This is a pain in the neck. So libraries like Neverthrow and Effect kind of make this a lot easier to deal with. So let's talk about the effect type. So the effect type is basically similar to a promise or an observable, except it has 3 type parameters instead of 1. When I say type parameter, you know how a promise has a T? You can put whatever you want in a promise, nothing, a string, a number, another promise. So when I say promise T, it's the type parameter, not the function parameter, but the parameter for the type because it's generic. So effect has 3. It's basically what is the value when it's successful, whatever success means, right? Error, and again, you don't have to have any of these. You could put never, just like you do in any other TypeScript stuff. But success means when your function comes back, what do you get? Error means if it failed, what happened? A lot of times error is going to be a discriminated union. You're going to have a union of unions, right? Where you're going to have this error, that error. So it kind of grows. But starting off, you can put 1 if you want. Just say string. I'm just going to log strings. I don't feel like creating error types. That's fine too. And that third parameter, requirements, is fascinating. If you know anything about dependency injection containers or frameworks, you'll know immediately what that is. And then when you read about layers, then you'll be like, wait, what? That's amazing. So this should get you really excited if you already know about dependency injection and the challenges with stubbing dependencies. The requirements being typed and the layers are going to get you really excited. So again, success, it succeeds, returns a value, fails with an error type. So each time, very similar to promise, it gives you a value back every time, but you have to open it up to see what's inside. The difference is that unlike promise, it doesn't explode. Observable can explode, but observable has a catch in place. So it doesn't explode outside of the observable, right? It doesn't affect the rest of the program like a promise would. So at least observable's cool. Effect will never explode, and they have 2 additional layers on top: global, exception handling, and other things. So it's kind of a neat feature. And yeah, the requirements is like, what dependencies do I need for this effect to work? Think about if you're a functional programmer, you inject your dependencies because of pure functions. So that requirements would be, what dependencies do I need this to work? What fetch function do I need? What service class that abstracts fetch do I need? Like whatever those functions are. And it doesn't have to be a function. It could be classes, but anyway, that's what those are. So here's a success example. If you just import effect, and let's say you're going to always return a success, this effect would return a number, but it would never have an error. And it doesn't really have any dependencies because it's not doing really any side effects. So it just returns a success with 42, right? And so that effect, you can safely type that I'm going to get an effect with a number in it. And a lot of people are very explicit when they type these things, but you don't have to. You can just kind of put a comma or just not put it at all. Kind of implies never. So you don't have to write all this. I'm being explicit here for the example. And so, yeah, can't fail, always returns an error, no dependencies. The fail example is, notice how we return a new error because it's an error type, but you don't have to. You could put a string, you could put an error code number, you could create your own errors. You could use discriminated unions. You could do it the effect way, where it's like a class with an underscore tag. There's a lot of different ways to create errors, but bottom line is you're creating errors and they're distinct from each other. They're not like an error class that everyone extends, although you can do that too. But the point here is, notice the type. It never succeeds. It's always going to return an error. And what kind of error? Well, it's an error class type, right? And it's compile time. You don't have to do instance of nonsense, which is kind of rad. So let's talk about the traditional way. So I've shown the custom error types. A lot of times the traditional way in JavaScript, you would extend error, and by default constructor, you just pass in a string. It calls a super. It sets, that's the message. But you could add other properties to that class if you wanted to, like an error code or, the error JSON, all kinds of ways to extend those errors to have more information about what went wrong. Perfect example is when an HTTP fails, what's the status code, right? A good example where you would want to attach that. So the effect way, they treat discriminated unions for everything. But if you're from a Scala, this should look pretty familiar. You're creating discriminated unions with classes. If you're a camel, that should also look normal. If you're not from one of those OOP, or I guess F# too, if you're not from an OOP friendly language, this might look crazy. You're like, why are they using a class keyword, but then treating it like a sum type? What? But that's how the Scala people do it. So, and yeah, again, on the bottom, if you have a program that could fail, when you fail it, you just put your new HTTP error. So the old traditional way would be your HTTP error. But the new way is kind of like, say, just make a tag, and you don't have to use a read-only tag. It's just for the people who are strict about immutability. But the point is, that's kind of their discriminant. I always write tag. A lot of the effect people sometimes do tag or underscore tag because they're implying like you're not supposed to read this. This is just an implementation detail for the compiler. So that's what that's for. On divide, let's say like a divide function, you would think 1 + 1 can never really fail beyond infinity per se. But division has a lot of problems. You can get math at infinity. You can get divide by 0, which is NaN, all kinds of other problems. And so effect is a good example of where a function can fail. You could either get a number back or you divide by 0. Like, you can't do that. We're going to give you an error back. And so this is an example where you would do a simple, I either have a number or an error, right? Notice there's no dependencies. So in this case, one of the two things will happen. You're always going to get an effect back, but it's going to be one or the other. And this comes into play because these types compound when you start using these functions together in pipeways. So when they say the word error tracking, what they're saying is what error is in that effect. It's very similar to if you have a bunch of functions that could fail with a union type of error. All the other functions that use it also include those errors. So it's kind of a nice feature of TypeScript, but effect does it really well. So when you've done error handling in functional languages, it seems completely normal because they're values. But if you've never done this before, you're like, why not just throw errors like that? Everyone's been doing that forever. And again, this is a very passionate subjective thing, but the math in functional language is not subjective. This is how they treat them. They are values. It's very algebraic or algebra style. In this case, why not we replace the effect with just a throw new error? What's wrong with that? Well, again, there's no type indication the function can explode, right? And that never helps. The issue is that if you change something in the code, the compiler can't help you that somebody way up here was hoping or expecting that error would occur in certain situations that I handle it, or maybe you change the name or the subtype. There's no type way to handle, errors. There is no checked exceptions, right, in TypeScript. So that's problem number one. Problem number two is that, again, something way over there unintentionally could affect it. So sometimes you might have a class expecting an error. Other times they have no idea. Promises can kind of help because you know that promises can fail. But if for synchronous code, if it could fail, you have no idea. So it's just a bad thing to have the program way over there explode and affect something over here. It completely defeats the concept of loose coupling and, doing cohesion over here. And suddenly that thing affects me. Like, what? I didn't even know it was coupled. And again, you have to at runtime look at stack traces. You have to use debuggers. And a lot of us from functional land, we don't use debuggers. We use loggers a lot, but we don't look at stack traces. It's usually from the types will tell us. Only in when we're integrating with JavaScript or third-party libraries that aren't typed very well, that's when we're like, all right, we have to whip out this stuff. So you kind of take that for granted. And when people say, well, just throw, I'm like, dude, I don't want to use a debugger. Like, why wouldn't you want to use a debugger? I'm like, imagine if you didn't have to use a debugger. Right? Like things like that, you just take for granted. So you can avoid all that with types. And effect is one of the better ways to guarantee all the error handling situations are handled in a single type, which is really nice. So again, I think we should compare it to promise again, because I think promise is kind of gone two paths in TypeScript. It's gone the imperative way with the people who are really all about await, but yet, when you get more towards await and imperative style coding, you care less about errors. If you're more of the pipeline and from functional world, it seems very nice, but there's no way to type what happened, right? You've got to return a union type for this value. And so it's just not good. So again, promise takes a value, effect takes a value and a custom error. So here's an example of delay, right? Delay is one of those things that it's a promise that can't fail. So if you want a promise that can't fail, you can guarantee that by in the catch returning a promise.resolve and just say, hey, it didn't work. And so it's a nice way to say well, the promise either worked or didn't. And that way you never have to worry about the promise exploding. It's what's called a safe promise. So if you ever use never throw, that's what they're talking about. Here, you can do an effect promise and then resolve with that message. And then if you notice the type, you're going to get a string, whatever that message is, but it's never going to fail. And it doesn't really have any dependencies. You're doing a side effect of a promise per se, but you'll notice in effect, you really don't care about side effects. You because the dependencies allow you to inject them from a type perspective. So even in your unit test, you're kind of less concerned about the stubs because the compiler guarantees it matches up, which is kind of nice. So again, that program, when you call delay on it, it's going to give you an effect back that, can't ever possibly fail. So that's when you say async that can't fail, that's what we mean. Async that can fail is if you try to do something that is what we call an unsafe promise. It's a promise that doesn't do error handling either in the initial part, or it doesn't return a promise from the dot catch to guarantee that the promise is in fact resolved with just different information. Like here's what went wrong, right? And so we call that an unknown exception. Again, no side effects from the type, but fetch can fail, right? You can have a 400 error. Your URL can be malformed. You can have no internet connectivity. There's a lot of things that can go wrong. And so that's what we mean by async that can fail. So Folktale 2 was one of the ones that had promises that you could cancel. And this was really useful in React JavaScript, where if you were having effects that you wanted to cancel. Now, cleaning a timeout, you're going to get a timer ID, so you can abort it before it even happens, right? Sometimes the HTTP request, you have to have an abort controller, and that is really awkward to inject. Most people don't do that in React. For example, they'll cancel, then you can do something else, like, oh, I want to clean up additional stuff, or mark it as canceled, mark the tasks is non-successful. So if you ever use abort controller, it's kind of the same idea where you get an abortable fetch, in this case, an abortable promise. But the idea is that not only can you deal with cleanup, but you also know when it was canceled. So pretty cool concept that Folktale had, but it wasn't type safe, right? And it was based on JavaScript. In fact, now you have type safe stuff and you have all kinds of concurrency controls. But the idea is if you're doing something async, like the set timeout way, if it succeeds, great. But if not, then you can clear the timeout when something comes back. So if you're used to use effect where you return that cleanup function, it's very, very similar. You just say, I want to clear it if it, stops early. So React use effect is a perfect example. I keep saying, like, what happens when you click the button a bunch of times, forward and back? Sometimes you get this kind of race conditions. So people who've started use effect and they don't really understand how use effect works, and they're also not understanding that it runs twice in dev mode, where it intentionally is trying to determine if they're pure functions, like not just your use effect, but all your code. You get into these weird situations. So abort controller is not just for fetch, but anything async. It's just kind of a mess. Let's talk about pipe versus imperative. So of course, I'm a pipe guy. I come from a lot of functional languages that have like ways of chaining things together. But the way they've done syntax and effect is so it feels imperative. And you'll notice that, especially from the OCaml world, not so much F sharp, but sometimes in the Rust and even in Scala, the imperative stuff is just so much easier to read and understand for some people. As long as the type system's good, like, it doesn't matter if it's imperative because the type system has your back. A lot of functional programmers make fun of imperative people because they create variables that could hold state and then break the program. That's really because they're probably in languages that don't have good type systems. But if you have a good type system, you can get away with writing imperative. Now, I'm not saying you should. I'm just saying that the syntax that they provided is pretty amazing if you know how type systems and async code works. So a pipe is very similar to every other functional language where you would, pipe it together. Since JavaScript does not have the pipeline operator, it's in stage 2 and it'll be in stage 5 by the time I have grandkids. So piping functions is a really nice way. It's very familiar with any functional programmer. And pipe will work not just for regular functions, but fetch as well. So each one of these takes a number. These types are kind of implied, right? I don't have a dot number here, but that's what it is. If you had an effect, the effect would know in TypeScript that it's, not type safe. And it would say, hey, if you get an OK back, are you going to pop out the number? What if it doesn't work? You're going to return an error. So they handle all that kind of for you with the compiler, which is kind of nice. The way they recommend it is the async await style, where they have generator functions. And you can always tell a generator function by the old school function declaration syntax, where you say function instead of fat arrow function with the star. And once you do that, you can yield or pause the execution of that function and return a value from that yield. You don't have to, but a lot of people do. And so what that means is each one of these could be an asynchronous style or synchronous, and it doesn't matter. It works with both, which is amazing. The other cool thing is that because it's an effect, it automatically will short circuit if it gets like an error and go to the error path. So if you know how like promise.then, it doesn't matter if you have 15 thens and it breaks and the effect goes down here, it automatically jumps to the catch. That's amazing, right? That's what promises do. Well, effect does the same thing. So kind of a amazing, feature they have built in. So again, they use yield and star. Like, a lot of people go, oh, I don't want to use generator functions, but this is not using a generator function. This is, I want to do effect in an imperative style without having to muck up my code with all this error handling. Do you see any try catch here? Do you see any dot catch or returning a resolve promise for async? No, it's not here. You can just write sync code and async code, and it's the same, just like RxJS, and all the errors are handled in a type safe way. That's pretty baller. So you can see why a lot of people go, oh my God, this is amazing. And they kind of look past the like, wait, why is this not have parentheses for actually calling a function? They kind of ignore those weird syntax things. So let's talk about dependency injection and context. So I think this is a feature that people who are very serious about either testing or test-driven development, or they're just testing. They don't care about test-driven development. They want the AI to code it. Whatever camp you're in, imagine if you could get rid of the joke of OOP, right? Where you grab a class and you drag like all the methods with the interface and all the things it imports. What if all that could like go away and you had a layer, right? And it was type safe. Most people don't think about that part, which the layer kind of blows me away. So let's take this process data function. You're trying to connect to a database, right? And notice there's no return value from that await. So functional programmers freak out because this is not pure and there's no way to extract the purity or the business logic from this function. There's no stub. So it's a global closure. You can't easily test this function. It was very clear that it was written by someone who doesn't test first or doesn't really care about testing or is mock happy, right? They don't care. They say they abstract things, but then the mocks know everything about their class and their functions and their child's classes. What we would do is say, no. Inject the dependency as a function parameter. In a class, that would be a constructor or a method parameter, right? So that way at runtime, you give it a concrete, but in unit test, you give it a stub or a mock, right? And so that way it's a lot easier to test a happy and unhappy pass. You inject the dependency. However, then you have to inject the window. You have all these dependencies. You're like, oh. So then they'll create like an object. So you only pass like in your dependencies. So that way you only have 2 parameters. But the second parameter is literally every dependency you need for your unit test or at runtime to get it. So they'll call it like context or something. So now the function's readable again, but it requires a lot of work to use it. Sometimes these higher level functions, like Lambda functions, whatever, they do a lot. And that's just the way it works. Show an example of how they do a dependency. So we have random here. Random, if you know like anything about math at random, it's a side effect. Okay. So we're going to do a random pipe and we're going to say we get a random number, we get the next random number, and we just print it out. So calling this program, it requires a random item. It could be a class, a function, doesn't matter. But the point is that's the dependency to get this to work. But notice it's in the type. So the effect requires this as a type parameter, not as a function parameter, but in the type. What that means is the real runtime. So this up here, real, is when you're running your code for real. You would give it a real random and it would just work, right? And it would call effect sync and call math.random. But in your unit test, you would provide the service for random that just returns like a number, right? So that way your unit tests always have 4. So for example, if you ever written a unit test that uses dates, right, the code could change based on when you run it. Because if you go new date, it could work today, but not tomorrow. An example is I'm working on code currently that deals with quarters, and today is third quarter. So we had some code that did some crazy stuff today because it's third quarter, right? I wonder like why we shouldn't use that non-determinism stuff in unit test. That's how you provide the real concrete value for effect is you provide the service. Think of it like a dependency injection container. And then in unit test, you just provide a stub or fake. So if you ever use vtest.fn, that should look pretty familiar. Your dependency is type safe. So this function guarantees that not only are you providing the correct one, but you also your stubs can return back the correct values, which is kind of cool. Other cool things, layers. Your dependency graph is typed. And the biggest issue with like bringing in a database is like, well, the database also has a connection. And so do you bring the connection class? No. If that's typed, Effect knows to only bring in that particular layer. And you can create these layers so you don't have to worry about testing everything. It's a very common thing that we've done manually when you're passing functions or functions to other functions. And you're like, dude, there's so many dependencies. Like I have to pass a fetch to it. And then the fetch, I have to pass like a board controller, which is also a side effect. Why can't I just port like a fetch that doesn't take any inputs other than this URL? Like, can I just do that? Yeah, you just type a function that what you want, and your unit test, you give it the stub and it works. And then your concrete, you give it the actual real fetch with the real function that wraps it, takes the URL. That's a lot of work. Effect takes all that work away. It gives you helper functions so you don't have to do it. And it guarantees that your unit tests are type safe when you're doing that. So you don't have to worry about runtime, compilation working. It's loaded on your dependencies. It has a built-in Zod. So if you ever use Zod or archetype or any of those other type narrowing libraries for TypeScript where you can do schema validation of like, I've got something from JavaScript. Is it really this type? It's built in. So all the Zod style validation is built in. So you don't have to, you could use Zod if you want, but Effect kind of provides it for you. And that way, if it errors, you don't get that array that is impossible to read with Zod, right? You have to build formatters for it and all this stuff or install other libraries. Effect, it gives you an error and it's a typed error and it's a schema error and it tells you exactly how it works and it's yet another effect, which is kind of nice because it just, batteries included kind of thing. So it's got queues. If you ever done any type of SQS kind of emulation and backend stuff, it's got queues in there. It's got pub sub if you ever done like sockets, for example. It's got a lot of other concurrency controls. But the point is, it's way better than promise all or array from async, right? Where it's like one after the other. Like you've got a lot other cool controls in there. You got retry, you got exponential back off, you got jitter, like all the things you would expect in network programming is in there. Streams and syncs. So if you ever done, message queues, first in, last out, or LIFO queues, they're all in there, which is kind of nice. The data types, it's got a lot of impressive data types that are growing. So like date time that includes POSIX, for example, like time zone, like little things like that you would expect that could fail or never fail, but are some kind of effect. It's all abstracted away and just built in, which is really nice. Things that you would kind of expect. Equality. So a lot of people in JavaScript are used to equal, where in functional programming, like a maybe of one and a maybe of one, they should equal each other. Even though their instances are different RAM addresses, like we mathematically think those are equal. And so that idea of equality with traits is in there and supported, which is kind of nice. They're abstracting all the platform stuff away from you. So you get effects if certain things didn't work, like standard out, standard in, reading files. You don't have to wrap all this crap yourself with effects. They've kind of built that in. And they're doing it for Dino and Bun, which is just nuts. Open source is rad. And they're also doing two things for AI. So I put MCP here for the plugins for AI that they're doing if you want your AI agents to talk to other things or reach out to other APIs. But they're also offering their docs in text so you can give it to like Claude. Because some of us are in environments where our AIs can't read everything, right? You can't just say, yeah, read my home machine, Claude. Like you got to drag it text. Let's compare it to RxJS. For some reason, gets an comparison to effect, but the thing with RxJS is that they don't really concern themselves with errors. They have great error handling. It's kind of stored in the observable, and even if you compose these observables together, you know if they fail, but you don't get types for that. So RxJS, when I say everything is an observable one or many, it makes async await style hard. There's no easy way to do async await. So this is for the imperative coders that want to do error handling where they don't have to care about the error handling. It doesn't make their code look ugly, and they can still, because they don't have to do try catch all over the place, right? They love that yield style, which is really, really nice. You can't really do that with RxJS because there's no guarantee, to one or many. RxJS takes a happy path and types, very similar to Promise, but not for errors. So like there's no way to do observable T comma error. It's always observable T and that's it. It's got one type parameter very similar to Promise. So there's no way to get an error back. You do get an observable of never, but that doesn't really work because we want like what happened, right? And so that concept just doesn't really work out. And then for front-end developers, they don't have really an incentive to care beyond logging, right? Because there's not much the user can do to fix their situation. For back-end developers using RxJS, it's a big deal. And so Effect is kind of like a nice level up from that. Effect is also single shot in that it enables devs to use the async await style because an effect is either it worked or didn't, or it had an array or whatever. It's not like observable, which could be one, many, or kind of like next, done. You know what I mean? And it also Effect handles happy paths, errors as types, and dependency injection. Observables don't really handle that. Effect is a library that you can use to build programs, but you could also just play. You could also play in unit test, right? You don't have to use Effect for everything. If you talk to the Effect people, they're using it for everything. But the idea is that it's really, really, really good at typing. It's got really good concurrency built in, resource management built in, observability built in. But it's got two ways to compose. So if you want to do the pipe way, like the old school functional programmers, you can do that. If you want to do the imperative way, very similar. If you ever use F#, where they have like I forget what they call them. I'll put the word up here if I can find. Scott Woloshin was talking about how you could do it to get rid of error handling in his book. But basically, it's a way where you just, very similar to class annotations, you say this could possibly fail. And you write normal imperative code, and it handles the error handling for you. No try catch, it's just handled. No dot catch, which is awesome. If you're feeling overwhelmed when you look at the docs, you're like, oh my God, dude, just use result. Like you just go effect.succeed, effect.in, that's it, right? And you get the typing. You don't have to worry about dependencies. You just go effect, it works with some data, or comma, it has an error. And the error could be a string, right? And that's a great way to get started. You don't have to use any of that other stuff. You don't have to use like your program is an effect and you run your program. You don't have to do any of that, man. Just play with the result. It's a great way to go in there and play with functional composition. The abortable promises is really nice if you're doing React and like you're not using React query and you're like, I want to have a way to have a type safe set of side effects that work, are unit tested, and I just want to drop them into a use effect and have the ability to be aborted. Effect's got your back, man. It's a great way to do it with use effect. Stateful servers where you're doing like express style stuff and you have to release resources. It's very easy to get wrong. I've done it with Oracle and Postgres, and they've got some good libraries for it, but it's just one of those things that's hard to get right. Using tasks around that stuff makes it really easy. And then some of the fine-grained concurrency is kind of nice when you're dealing with like orchestration layers. If you're ever like a Node.js developer and you're an orchestration layer, your job is to call downstream services and then, smash the response together to give to somebody else, whether it's a front end or another API. This is really cool because it has the ability to retry and then exponentially back off. So you're not like hammering downstream services. The only cost of that is like, longer SLA. So kind of nice that it's kind of just built in and handled. Very similar to like a lot of the observable stuff where they would like retry for you. It's kind of cool. And again, services allow easier dependency injection with support for multiple platforms. Like again, I know Dino and Bun are like most people are more multi-cloud than they are for multi-runtime, but it's still kind of cool that you can do that. But I just again having a dependency injection that's type safe, that helps. I know with Jest and Vite test, they've got really good things on the mocks now that detect your types when you mutate your concretes to stub things. But having that for dependencies where you can provide your own implementation is it's amazing. So definitely check out Effect. It's got way more to offer than this. If you, I'll link to the Matt Pocock video. He'll do a deep dive. He's a very famous TypeScript guy. He'll give you a lot more details about it. But yeah, definitely worth your time to check out. You can go to the Effect website. My original Twitter post, this is last summer I talked about it. If you want to see the OG, check out Scala Zio. And again, my contact info if you want to reach out. I'm happy to help.